In this example problem, we have a pickup truck with a hitch that's trying to pull a stump out of the ground. The hitch is higher than where the rope is pulled to the stump. We have a force of 800 pounds acting to the left. And the question is, what is the force in the rope in I, J, and K notation? So while this is a kind of realistic scenario, we want to turn it into a more simple thing that we can work on. The first thing we're going to need to have is our coordinate system. So I'm going to say I have a y-axis going up and an x-axis going to the right. Call that x, call this y. In terms of the rope, if the rope is putting a force on the stump going to the left, that means there's going to be a force in this rope here going to the right. So I will say that I have an 800-pound force going to the right. The rope force is going to be acting up and to the left. And I have a distance here, 12 inches. And my rope has a length of 48 inches. So the first thing I'm going to do is figure out what my angle theta is here. And I'm going to say that the inverse sine of 12, which is the rise, divided by 48 is equal to 14.5 degrees. So theta equals 14.5 degrees. So if I want to know what the force in the cable is, we know that to get the I component or X component, which the 800 pounds lines up with perfectly, we would take the force in the vector and multiply it by the cosine of theta. So we know that R, which will be the force in the rope, is multiplied by the cosine of 14.5 will equal 800. If we solve this, we find that R equals 826.32 pounds. So if I'm putting this in I, J, and K notation, if I have the resultant, I can do R cosine of theta and get the I component, which we already knew, 800 pounds. Now, the stump is putting a force to the right of 800 pounds. That means the force in the cable is going to the left, so our I component will equal minus 800 pounds. Our J component is going to equal 826.32 sine of 14.5. So the J component equals 206.9 pounds. And since the cable is going to the left, everything in the I is going to be negative. Everything is going up, so everything in the y is going to be positive. So we're going to have minus 800i plus 206.9j. Since I could draw this whole thing on a piece of paper, I have a two-dimensional problem, so the k component will equal 0 pounds. So if I wanted to write r in this notation, I could say r equals minus 800i plus 206.9j plus 0k. Or if you don't want to write 0k, you can eliminate that